You're listening to MedX, the Medical Extrusion Podcast, presented by US Extruders. Extrude with confidence, custom extrusion equipment designed for you and your application.
Hey folks, welcome back to the MedX Podcast. Today's guest is Andreas Perjus, the CTO of Optinova Group. Optinova is a world-leading extrusion partner for advanced medical and industrial tubing. Enjoy. Hello, Andreas. Thank you for carving some time out to join us on the MedX Podcast today.
Thanks for having me, Steve. It's great to have an industrial collaboration space like this. I think sharing and learning across the extrusion industry is great, and I appreciate that with your podcast.
Thank you. That's what it's all about. I know we have some interesting topics to discuss related to heat shrink, secondary operations, and value-added services. But before we do that, if you could please just kind of give a snapshot overview of Optinova, your extrusion portfolio, headquarters, and where your manufacturing operations are located.
Yeah, absolutely. So we are 50 plus years of extrusion experience as a company. We are maybe not the most vocal out in the industry, but since a long time back, we have, with our headquarters here in Finland, we have been working with the fluoropolymers, evolving into the medical space in the 1980s, and then also 10 years ago, taking on other industrial segments with advanced tubing requirements. Currently, we have factories in the US, in the Europe, and Asia. And at the moment, seeing an amazing growth and the medical side evolution that is really, really amazing. So basically, we extrude. We don't do medical device. We don't do raw materials, cables. We are fully focused on extruded tubing and value-added services. So we do fluoropolymers, including PTFE, but also non-fluoropolymers of various sorts, now also including PEEK and other more, exotic materials. So we do single, we do multi-lumen, single layer, multi-layer, various co-extrusions, and more or less everything in between. Manufacturing is our mainstay, but we also do R&D services for selected partners in various forms. And maybe a bit of a fun fact is that we were part of designing and mass producing the modern IV catheter solutions almost 50 years ago. And that's our birthright, so to say.
I would imagine the number of IV catheter tubes that you've extruded over the years is in the millions.
I think go one level up.
Yeah, billions.
The billions.
Yeah. Excellent. You talked about the evolution, and I know that you have a next generation of your FEP QuickShrink 2.0, and I'd like to see if you could talk a little bit about that, what the properties are, and some of the unique benefits for catheter manufacturing.
So, Steve, I mean, we know heat shrink is a process tool, right? Supporting catheter manufacturing and has been around a long time. But what we have done together with customers, we have developed a design of heat shrink. We call it the QuickShrink, which is optimized to work in demanding environments like this. Quality, of course, first and foremost. Really high stability of the product across key properties, but then performance also for our customer, the catheter manufacturers. So the QuickShrink is designed with a couple of specific properties. It's not the shrink ratio. It's rather other properties within the catheter manufacturing. So where you need a tight fixation control, you want an early and fast shrinkage to fix everything. That is what the QuickShrink is designed for. And on top of that, if you use regular temperatures, then you also get a much stronger force. But you can use it with the lower temps, and in an environment where the lower temperatures than a regular heat shrink, FEP heat shrink, where that is beneficial, the QuickShrink will make your life a lot easier. And then also production efficiency. The QuickShrink, it shrinks a lot faster than the regular heat shrink. So that means that as a catheter manufacturer, you can optimize your processes and speed it up quite a lot.
Mm-hmm.
So all in all, the QuickShrink is a low temp, high precision heat shrink product that is optimized for the catheter manufacturers or other demanding applications.
Okay. Sounds like it can help with cycle times as well.
Exactly. That is one, of course, a key thing. Efficiency is important for everyone, but also combined with the quality. You want to have it, the shrinkage and the fixage, you want to have that exact and consistently every time, basically.
Right. Okay. Thank you. Let's move on to, I want to talk about the PTFE Zebra spiral heat shrink that's used for endoscopic devices. And correct me if I'm wrong, but I believe it's for covering guide wires. And I can understand why you'd cover a guide wire with a PTFE for lubricity, but what are the benefits of the spiral kind of zebra patterns, color patterns on the endoscope, guide wire?
Yeah. So in itself, this is not a very complicated property in itself. So this is the visual aid for the clinical personnel to see basically how does the movement of whatever equipment they have on the guide wire, how does it perform in the endoscopy.
Okay. It can any different combination of colors be used?
I think this is not functionality wise. I think this is more kind of either you use that as a brand or it's kind of what feels good. So we can offer different colors, almost any colors, but of course we can also customize the frequency or the pitch of the stripes in this heat shrink tube. So I would say that from that perspective, it's quite clear. I mean that the Zebra Shrink is something to ease up the use of the clinical experts. But these are small dimensions. I have one sample here I could show.
Yep.
You can see this black and yellow Zebra heat shrink, PTFE, and they're small dimensions, as we can see, and up to a 4:1 expansion ratio. So of course that gives some requirements on the extrusion and of course the expansion process. But then you add these dual colors as well, the black and the yellow, and also remembering that in the actual extrusion the different colors have slightly different behaviors, and then also adding the pitch stability and ensure that it remains exactly consistent over the batch. All in all, this becomes a pretty complex tubing to produce, and I'm really happy that creating the process what we have right now and being able to give this qualitative and consistency out to the customers, so the clinical requirements can be met. It has been an interesting journey, but it's that's the evolution continuous in the extrusion space.
Absolutely. You talked about the clinical application a little bit. Are the colors, are they radio opaque, or is it more just camera based visualization for an application like that?
These are not radio opaque, or these are visual for human eye, or might also be part of some visual aid equipment. I don't have the full information on that.
Okay.
But a visual. Yeah.
But it's not radio opaque. Okay. Awesome. Since we're talking about some pretty interesting fluoropolymer based applications and technologies related to extrusion, we have this lingering issue, regulatory concerns with PFAS, forever chemicals. And since we're talking about fluoropolymer based solutions, can you share your thoughts on, some of the challenges we're all seeing especially I think in Europe, a little bit more so related to PFAS regulations.
Yeah, and I think this is actually now a field that is evolving quite quickly. I mean, different happenings both in US, I think US actually more recently now, and Europe. So US and Europe has have different approach. In Europe, there has been a kind of a, okay, all PFAS is bad, let's ban everything. And look at some exception times. In the US, there is rather a discussion about, okay, different industrial sectors and what is unnecessary use and what is non-avoidable uses. So there's a bit different approach to this, but in general, I mean, also knowledge in this area is very limited. That is what we see. I mean, PFAS in itself, it's a huge group of substances, right? And some of them are already prohibited since many years, like the PFOAs, etc.
Yeah.
So and the main concern is this short-chained PFAS substances, and that is not the fluoropolymers. They are long-chained, and this is something that there are emissions in the life cycle also for fluoropolymers, but in an essence, I mean, the fluoropolymers is still on a very good side of the whole PFAS spectra because they are compatible with humans, so biological compatible. They do not break down in the nature. They don't cause any additional pollutions. So legislation is black and white. We know that, right? Tend to be like that. So where do we go from here? And I think the good thing right now is that both in Europe and in US, it looks like the legislators are actually listening to the industries. And it doesn't seem like this is a very fast process, not even in Europe, where they have said that they would have some kind of legislation in 2025. It doesn't look like that is happening at the moment. So what will this mean? What will this mean for extrusion operators? What will this mean for the medical device industry? Well, cannot really say with 100% certainty. But what we can say is that there will be some changes, right? There might be changes in the supply chain. We're seeing that already. Some pulling out, some doing strong development efforts. So that is happening. And also, of course, from a medical device industry, where when you start a new development project, what do you look for? So this is the PFAS. We don't really know. We know that the PTFEs and the FEPs and the PFAS, they have very strong properties in many areas. So they will not go away for the short term or the midterm. That is for sure.
Yeah.
But I think that also the flexibility is important for extrusion operators. We need to be proactive now and develop new materials and processes. So, I mean, there are mega trends coming from sustainability, of course, but supply chain security, all of this. So together with the PFAS, being proactive, run new materials, additives, compounds, I think that is the keys when you look at PFAS as a whole.
Yeah, excellent. Thanks. That excellent summary. Thank you so much for that. I think you're right. It's not black and white, right? And we need to really help to educate the world about this.
Yeah, and be proactive and run various testing programs or whatever you can do as companies. And I think the compounders, for example, you have had several here on the podcast, and they're also doing a good job to create various alternatives with or without fluoropolymers.
Right. Excellent. Let's talk a little bit about some value-added secondary operations and capabilities related to design services, and we'll start with secondary operations. Can you just kind of give us a brief overview of some of the value-added capabilities beyond extrusion that you offer?
Yeah, there is a range of various types like braiding, heat shrink in itself, flaring, welding, skiving, different types of manipulations. Basically, printing is one of these, and it's a toolbox, right?
Yeah. Are there applications or programs where you get to significant volumes where you need to, scale and automate some of these operations? Have you run across that?
Yeah, I think this is a little bit the kind of running point, I think, as an extrusion operator today, which provides this type of value-added service. You need to be able to scale. And you can have a toolbox. You can be able to do prototypes for all these types of value-added service. But then when push comes to shove and you have a customer that really wants to scale, then there is specifics. There is specific raw materials, tolerances, whatever compliance and dimensional needs. So you need to work for those specific requests. And at that stage, I think the value-added service goes from this prototyping into a type of a industrial scale. And here is where well, we see, at least from our perspective, that having access to a kind of design competence to be able to build or design and have built your equipment for these large scales. Is that robots, or is it automation cells, or whatever it is, something you can purchase like braiders. But for some of the other manipulative value-added services, you might need to customize them in order to do high volume production.
Okay, interesting. Let's move on to design services, and if you can maybe give an example of some of the design services that you provide, or a particular project that you might have worked on that you can share at a high level.
Yeah, we could maybe stay then in the value added service space, because this is also something that's very strong on my mind. We received a request from a customer that they are getting clinical feedback about a specific device that they have on the market, and saying that, hey, this doesn't really work in the clinical space. The users destroy too many of these devices, so we need help. We need this mitigated. We already had components into that device. So we sat down, discussed this, dissected the problem. I think that is really important, that you're open. You can discuss with your customers and help them solve problems. And came back, understood the problem. At least we thought we understood the problem. Created a design proposal and continued to work with the customer. And then few iterations, we moved forward, and then at some stage we had a design that was approved. This is the next step in this. Then of course you move into the implementation. Then the supply chain comes into the question, and how do we scale this? This is an own market device. How do we get it out there fast? Our clinical feedback, no good. So here we proposed then a phased approach, where the first step, this is kind of a semi-automatic. So we want to ensure the quality of the products. That is always the key. But in this phase, that the go-to market was more important than the efficiency. So for the short term, this is the kind of, the balance that you need to think about, right? And so then we had designed individual automation cells and tooling sets, because this was a multi-type SecOps, and we implemented that to be able to to cope with a lower volume at the beginning, and we could see this worked. The builds of the products, the devices that worked well, they got out on the market. And then as a second approach or a second phase to this, then we proposed a fully automated robot cell where we could incorporate all these individual steps of the value-added services. And then we launched that after, of course, that took some time to implement, and then we launched and could scale a lot faster together with our customers. And that is how we could match this with good collaboration, a value-add service toolbox, and the automation capability, and a collaborative mindset. Then we could match the aggressive go-to-market pace, but still keep the quality always in mind while doing this. So this is a kind of okay, all projects, to be fair, they do not end up like these successes, but this is a good example of where all these different types of tools in your toolbox really can help your customers take the steps, even if the go-to market is very important in the beginning in a qualitative space like the medical device. So this was a very interesting project and something to learn from, and that we have since developed.
Okay. Yeah, thanks for sharing that example. That's very interesting. Let's kind of wrap things up with talk a little bit about the digitalization of medtech and data acquisition. I recently had some folks from Symmetry Laser, Nick Zanobini and Jay Vincent. It's basically a startup organization that is involved with laser welding, laser cutting of hypotubes. And they talked about how they started from the ground up with a paperless system, data collection, real-time data collection to streamline their operations. Can you share how you're kind of embracing the digitalization and data acquisition in your manufacturing environment?
First of all, I think I should say that I'm really envious starting from the ground up with a clean slate, right? That's the dream.
Yes.
With a 50 years of history, the environment is a little bit different. But but I think, and I think you have mentioned this previously as well. I mean, in this industry, extrusion, we talk about craftsmanship, right? And I think that is right. I had the fortune to celebrate a colleague of ours off to retirement a couple of months ago. He had worked for more than 45 years in the industry and at Optinova. His memory was amazing, and he really embodied this craftsmanship. But we are talking about digitalization, right? The world is changing. The wheels are turning faster. Employments are shorter in time. Not so many that spend 45 years in a company or even in an industry anymore. And requirements are getting tougher. So I think that we need to move into the world of digitally supported craftsmanship. We need to keep this both, digital support and the knowledge and craftsmanship. And I think that, I mean, there are a few things that are enablers here. I mean, real-time data collection, how to give the feedback to the operator. Where are we compared to where we should be? How is my tempo? How is my quality? That this is very transparent, so you can drive continuous improvements, Kaizen programs with transparent data. That is one key, I think, and something that we are very playing with a lot at the moment in Optinova. But then we have the extrusion engineers, the development teams, and what do they need from this? They need the aggregated process quality, efficiency data in some kind of tool that can be easily analyzed. And we have also been playing a little bit with this, and it is amazing what insights you can get when you take a broad range of data from one extrusion line, for example, from the puller cutter, from the extruder, the cooling bath, from the winder, and combine and cross-link these. And we had an example, a case where you could clearly see the correlation between the malfunctioning pressure sensor and its effect in the pressure control feedback loop in this type of data sets. And this is something that maybe would have eluded us without this data. And I think that's amazing for the engineers. And then combining this with AI, I mean, you might have used ChatGPT or something similar to learn more about different things. And there are now coming these custom GPTs, so the pre-trained language models. And basically, what can we do with this? I mean, we can give engineers a digital assistant that has access to a lot of knowledge that the company or even the industry has gathered over time, and provide that when needed. So all of this, and then together with a digital environment where you manufacture and document digitally, then we are in a really good state. So I think that we are not fully there yet as Optinova, but I think we and many others are working in this direction, how to traverse this digital information. There are no direct standards, and I'm assuming also US extruders are working with this to create what are the interfaces from your equipment to your customers, and how do we use all this abundance of data that we have. So there's probably not any silver bullet for anyone, and it's individually for different companies. But I think we need to work, everyone, in this direction of the digitally supported craftsmanship.
Excellent. Wow. You said you're not, the industry's not there yet, but clearly you have a vision at Optinova for what you can do. And I love that example of how you could have data information to an extrusion engineer or operator at your fingertips like that. That's amazing.
Yeah, I think we will probably see an exponential growth in usage of this type of data. And as with everything else, I mean, there is an abundance of data. How to turn that into smart actions, I think that's the challenge.
Right, absolutely. Excellent. Andreas, this has been a really great conversation. I really appreciate your time.
Thank you very much. It's interesting to share a little bit, and also to be part of this. As said again, thank you for pushing the industry.
You're welcome. I really enjoy it. And this has been a great conversation.
Thank you for listening to MEDEX, the Medical Extrusion Podcast, presented by US Extruders. Please subscribe to make sure you're getting the latest episodes. For video episodes, go to us-extruders.com/podcasts. All links are available in the show notes.